Okay, in example 4, part 1, you're being told to find the terms of the sequence, the first four. So there's the way you find them is just basically plugging in some numbers into the formula, the recursive formula that's given, but 0 and 4 were already given to us by the problem for free. So we just copy them, and the additional ones, you need to get them by relying on the old information. So 4 goes here, 0 goes there, and we get 24, and so on and so forth. So what I'm noticing right now is that there's a 0, there's a 4, there's a 24, and there's a 124. So they all look like powers of 5, but maybe take away 1. And that's the purpose of the next part of the question, is to show that this pattern is actually going to hold. So every s that we come up with is going to be a power of 5, but take away 1. So the proof relies on strong induction, and there's the beginning of the proof. I did 2 base cases, again, because my recursive formula goes from k to k minus 1, that's 1 step. From k to k minus 2, that's 2 steps. The larger one is 2, so that's why I'm doing 2 base cases. And in both base cases, S0 is going to be 0, but that's a power of 5 minus 1, and then again 4 is a power of 5 minus 1. So the theorem is true so far, and I move on to the inductive hypothesis. So what am I doing in there? I'm supposing that the terms basically are all generated by the formula 5k minus 1. And I would like to show that sk plus 1 can also be generated with the same formula. To do that, I'm going to rely on the recursive formula that I started with. So I'm going to say we know that. So sk is 6sk minus 1 minus 5sk minus 2. And we're going to go ahead and replace k with k plus 1 to get the next term that we're interested in, sk plus 1. So we get the new formula sk plus 1 is equal to 6sk minus 5sk minus 1. And because of the recursive formula, we can make some substitutions for sk and sk minus 1. Both of them have indices that are in this list, so they can both be written in the power form. So here we go. And so now it's just a matter of doing what we did on the previous example, where we FOIL everything and combine like terms. So I'm about to do that right now. But then keep in mind that 5k minus 1 multiplied with 5k, they both have the same base, so we can technically add the powers. And we also have 6 minus 5, which are like terms, so we can combine those terms together. So this is the outcome of the additions that we did on the previous step. Now keep in mind that we have 5k over here and we have 5k over here. There's like an invisible 1 in front of it. So technically that makes these two kind of sort of like terms. So we can combine them. 6 minus 1 is going to be 5. And finally 5 times 5 to the power of k is going to be equal to 5k plus 1 minus 1. And this is exactly what we were looking for in our statement up here, where we wanted to show that sk plus 1 is 5k plus 1 minus 1. So that's a pretty cool theorem, and we're basically finished with this one. So see you in the next video.